Based on my last video on basic of screen view for screening air dispersion model, we're going to solve a problem in this video. Consider a single air pollutant emitting stack located on a simple flat terrain in a rural area. The point source has the following parameter. Pollutant emission rate is 1 gram per second, stack height 35 meter, stack inside is 2.4 meter, stack gas velocity 11.7 meter per second, stack gas exit temperature is 432 Kelvin, ambient air temperature 20 degrees centigrade. By using full meteorology, determine the maximum ground level concentration across a range of automated distance from 100 meter to 300 meter, and keep all other options set to default or no or unchecked. So the terrain is simple, elevation is flat, dispersion coefficient is rural, and uh, flagpole receptor is at 0 meter because we have to identify the maximum ground level concentration, and full meteorology is used for simple terrain, and minimum automated distance is 100 meter and maximum is 30 kilometer. So this is my screen view. If you have any project, then hit here the open, otherwise hit new. So I create a new project and give a name example 1, save, and you can see that the source type is point, dispersion coefficient rural, flagpole receptor is 0 meter. Now I enter here the pollution source parameter as given in the problem. You can see here that there is a drop down under the stack gas exit velocity and flow rate, and it is a convertible. So then hit next here. The slope terrain is simple, terrain option simple, flat terrain, select the automated distance here and keep this default, animator is 10 and full meteorology is here. Next I hit next and give this is complex terrain, so it is inactive. Then hit next, automated distance here, so I put 100 for minimum distance and 3000 meter for maximum distance. Go next, discrete distance is null, go next, next, fumigation, next. So when I hit next, this page will appear and you will see the input value here and the project is complete. If not, then incomplete is there, then hit run. Once I hit run finished successfully, graph and output file is generated. This is also available from this option. Once I hit graph, you can see that this is automated distance percent concentration graph is there, and you see that the maximum concentration is nearly 3.9 microgram per meter cube at 900 meter distance. You can change plot style from line to point to bar or area, and you can change off this shadow option by selecting data shadow, apply. So, and you can save this graph by export to bitmap. So I keep the name is example 1 for this graph also. Now I going to the folder where this graph output and input file is set. So you can see the graph that I just saved, and I just open the input file. You can see P for its point source, one is emission rate, 35 stack data. All the information is available here. The Y for this is automated distance, 3 minimum and maximum distance is there. So, and if I go to the output option, this is actually the result. So you can see that simple train option all are there. You can also find buoyancy flask and momentum flask here. And the full meteorology is used here. You can see that this is the distance of 100 to 300 meter. This is a 30 array of 100-meter interval, and this is the concentration of pollutant. And you can see that maximum 1 hour concentration at or beyond 100 meter is 3.789 microgram per meter at 892 meter distance. So this is actually the result here. You can see that the maximum concentration of pollutant is 3.789 microgram per meter cube, and this is at a distance of 892 meter from the stack. So in simple train, screen 3 calculates 1 hour concentration estimates. In complex train, the model provides 24-hour concentration values. And for point and flares, US EPA has a multiplying factor to convert 1 hour concentration to 3 hour, 8 hour, 24 hour or annual by multiplying the factor as shown in the table. However, EPA has not developed any multiplying factor for volume or area sources. Here I can want to mention it that for annual means annual arithmetic mean of minimum 104 measurements in a year at a particular site taken twice a week 24 hourly at uniform intervals. So we have 52 weeks in a year. So if twice in a year, so this is the measurement is minimum is 104. And 24 hourly, 8 hourly and 1 hourly monitored value should be met 98% of the time in a year. 2% of the time it may exceed the limit, but not on 2 consecutive days of monitoring. So thank you for watching this video.